Welcome back, children. Welcome to Refresh Concepts with me, Dinesh Modi. Now, in construction, what we are going to see is steps for construction of incircle and circumcircle. So we are about to go and draw incircle and circumcircle. But before that, we need to know how to go for incircle, circumcircle. What is the difference between drawing a circumcircle and incircle? So these are the steps which I'm going to draw freehand. We don't have any instruments as we have learnt earlier also. But yes, I shall be giving you all the difference between circumcircle and incircle, how to draw for it. At the same time, I shall be giving you some tips also. Remember that. So to start off with, let's start with incircle. Right? Now we all know that when we go for circumcircle and incircle, we mainly have triangle. That means we are going for incircle for a triangle and circumcircle for a triangle as per our syllabus. So this is what you can say, that we are drawing a circumcircle and incircle for a triangle. So triangle is what we know how to go for drawing a triangle, right? Every single child knows how to draw triangle. Maybe 3 sides are given, maybe base side and 2 angles are given, maybe 2 sides and included angle is given, or some other forms of triangles are being given to us. We all are aware about how to draw different type of triangles, right? The point is not drawing the triangle, the point is how to draw incircle and circumcircle. So say we are being given any triangle as such. Say we are being given any triangle as such, we are going for incircle. So we have a triangle ABC. We have a triangle ABC, right? So it's not an equilateral triangle. If you think so, it's an equilateral triangle. No, children, it isn't. What is the first step? Out of the 3 angles, we need to go for angle bisector of any 2. Once again, having drawn our triangle first, right? We need to go for angle bisector of any 2 angles. I prefer the base angles. If you want, you can take B and A and C. I prefer B and C. Mind you that this is an acute angle triangle. This is an acute angle triangle. So when I say I want to go for an angle bisector, you all are aware about how to go for angle bisector. If not, you can refresh the basics which I have taught. How to go for an angle bisector, perpendicular bisector, everything is being taught to you earlier. So kindly refresh the basics. Now with B as a center, any suitable radius, I'm to go for an arc. I'm going to go for an arc here and arc here. If you want, you can go for a straight arc. I repeat, with B as a center, an arc, any suitable radius and an arc. If you want, you can take an entire arc. Now, these are my reference point. Mind you, I am making it large for you people to see. You do not make it that large. You did not make it that large, right? So these are my 2 reference point. Now, with this as a reference point, increase or decrease the radius depending upon the radius you have, right? An arc inside. From here, cut. Likewise, cut. Once again, from here, cut, cut, same radius. What next? Then, can you see that this is what my point B was, and now this one, right? I just need to go for a straight line. I just need to go for a straight line. Mind you, what I have drawn is nothing but an angle bisector. Since I've gone for an angle bisector, this sign is what you are supposed to show. This sign is what you are supposed to show. Right, children? Once again, we have the triangle in front of us. We have drawn the triangle from our side. Now, what is the step? The step is go and draw angle bisectors of any 2 angles. Go and draw angle bisectors of any 2 angles. So we have picked up B and we are going to pick up C also. So what we have done then, with B as a center, any suitable radius, cut, cut, or you can go for entire cut. These are my reference point. Increase the radius, decrease the radius, whatever you want to take, arc, cut. B to that point, any problem? Whatever we did for B is what you are supposed to do for C. Absolutely the same. So now I have C here. I have C here with C as a center, cut, cut. Now there are many who might be wondering and asking themselves that is this the same radius we are going to take here? May not be. If you want, you can take it, but it's not compulsory. There is no norm that whatever radius you have taken here is what you are supposed to take it here. Mind you, It's your call, totally your call. You can increase, you can decrease the radius. Any problem, children? Right? Now, from here also, any suitable radius, go for an arc cut here. Let me draw with the different markers so that you can understand it very well. From here, cut, and then from here, cut. Now, do I have this particular point? Do I have this point C? Go and join it. Immediately, sign needs to be shown. Can you see that? This is what is needed. Now, can we see that we have point of intersection? As I stated, I am making it large, you need not make it large. This point is termed as incenter I. This point is termed as incenter I. Now from I need to go for a perpendicular onto the base. I have to draw a perpendicular onto the base. And what is base? BC. So we have learnt something called as how to draw perpendicular from an external point in our basic construction, this slide. How to go and draw perpendicular from a point outside the given line. So with I as a center, any suitable radius, mind you, with I as a center, any suitable radius, cut. It should cut my BC at two distinct points. I as a center, any suitable radius, cut. So here 1, here 2. I said any suitable radius, mind you. I said any suitable radius. Are these my reference point, children? Are these my reference point? Now, from here, increase or decrease the radius, depending upon the space you have. From here, cut, same radius, cut. An arc, that means, when I say cut means an arc. An arc out here, an arc out here. Did I get this particular point? I do have this point I do have this one. I just need to join a straight line. I'm sorry, we are not having a straight line. As I said that we are going freehand. So maybe my arc and point of intersection and may not be that straight. So this is what is perpendicular. Immediately I need to show this line. This sign is what I need to show. Right, children? So once again, let me repeat what we have done up till now. A triangle is what we had drawn. Then we went for angle bisector of any two angles. We have picked up the base angles. B as a center, any suitable radius and an arc. These are my two reference points. From here, any suitable radius, cut. Make it. We have gone for an angle bisector. If you want, you can name it also. If you want, you can always name it also. Right? You can say this as BX and this as BY. BX and CY. Thereafter, whatever process we adopted for B, the same is what we are going to go and do for C. Point I is the point of intersection of both the angle bisector. From I, we need to draw perpendicular onto the base. I is the center, any suitable radius, cut. It should cut my base at two distinct points. These are my two distinct points, mind you. Once again, I can show you this one and this one. So my arc was here and my arc is here. From here, increase or decrease the radius depending upon the space you have. This is a point. From point I, join. Immediately perpendicular. Now, this point is point M. That's what we have taken it. This point on BC is what we have taken as M. I as a center, I M as a radius. I as a center, I M as a radius. I need to go and draw a circle. I repeat, I as a center, so I need to have my compass ready with me. My compass is ready. I as a center, and how much should be the radius? From I to M is what I'm going to keep my compass. I as a center, I to M, and immediately go for a circle. The moment I go for a circle, I'm going to get somewhat of this kind. I can understand, even you should understand, that sir is going without construction box, but this is how your circle will look like. It will touch all the three sides of the triangle. That's what the definition of incircle is. I could have stated that first also, but I wanted you to learn by drawing it. You learn the definition. In fact, you should, understand what exactly incircle is. Incircle is nothing but when a circle touches all the three sides of the triangle inside the triangle. A circle touching all the three sides of the triangle inside the triangle. This is what an incircle is. Right, children? Now, this is what we have for acute angle. Likewise, the triangle could be a right angle triangle also. Likewise, you can have a right angle triangle, mind you. Again, the process is the same. Angle bisectors of any two angle. You can go for this one, you can go for this one, then perpendicular, and then you can go for an incircle. Or for that matter, if you have an obtuse angle, then obtuse angle, angle bisector, you can go with this one, you can go with this one. Mind you, for obtuse angle, you have to be very careful, as you will be slightly on the, one of the side, towards the edge of one of the side. And then again, the method is the same, drawing a perpendicular and then going for a circle, mind you. So these are acute angle, right angle, obtuse angle. This is what an incircle for a triangle is. And what is the definition of incircle? A circle touching the sides of the triangle inside the triangle is what an incircle is. How about circumcircle? Now I want you to tell me the definition or explanation of circumcircle. If this is a circle touching the three sides, if a circle touching the three sides is termed as incircle, then a circle touching all the three vertices, or rather passing through all the vertices, I have to be very clear in my language, a circle passing through all the three vertices is termed as a circumcircle. So let's see now what is circumcircle and how an incircle gets differentiated from circumcircle. So again, triangle is what is given to us. So we all know how to go and draw a triangle. So say a triangle is given to me. Say a triangle is given to me. Mind you, a triangle is given to me. Now for incircle, say this is triangle again, PQR. Say this is PQR. For incircle, what did we do so? I wanted you to understand the difference, and that's the reason I'm showing you side by side. For incircle, we went for angle bisectors of any two. Though we had three angles, but we went for any two. Likewise, over here, we need to go for perpendicular bisectors of any two sides. Angle bisectors of any two angle out of the three. Perpendicular bisectors of any two sides out of the three sides. There are three sides, PQ, QR, PR. I intend to go for perpendicular bisectors of any two side. Right? Any two side. I shall prefer one base and one of the incline. Choice is yours. Call is totally yours. Now when I say perpendicular bisector, again you should be aware about it. If not, refresh in the previous slides what we have learned in the basic one. Q as a center, more than half of QR, arc up, arc down, R with the same radius, Q more than half, cut, do not change the radius, R, cut and cut. Right? What did I get? I got first perpendicular bisector. I'm sorry, as I said earlier, that we are not having any instruments with us, so maybe my arcs will not coincide with my actual lines. So this is what maybe. Immediately what you need to show is, since it's a perpendicular bisector, what are the things the examiner is looking out for? A 90 and this to be shown. Say this is M. Once again, Q as a center, more than half, R, cut. Go for it. What do you need to be, sure about? Point M, 90, perpendicular sign. Whatever I did for QR, the same thing is what you need to do for either PQ or PR. Choice is totally yours. What I shall do? I shall go with PQ. Again, Q as a center, more than half of PQ. Q as a center, more than half of PQ. An arc outside and an arc inside. Arc outside and an arc inside. Now those who are wondering that, sir, whether these arcs coincide, so is it a problem? Never a problem. See to it that you don't get that many arcs very close by each other, so that you only don't realize your point of intersection of both the arcs. There is no harm if the first perpendicular bisector and the second perpendicular bisector arcs coincide. You should be aware which point you are supposed to take. So once again, Q as a center, more than half of QP, arc out here, with the same radius, cut and cut. So this is what it is. So now I'm going to go for perpendicular bisector of PQ. So when I say perpendicular bisector of PQ, somewhere of this kind I'm going to get it. I'm sorry, quite tilted line is what I got it. Say somewhere of this nature is what I'm going to get it. So I try to form my arc here from my side. Here it is already getting coincide. Immediately what I need to show, perpendicular and not the same sign, different one. Now did I get the point of intersection? Here also I got point of intersection. This is termed as incenter, this is termed as circumcenter. This was termed as incenter. For incircle we have incenter. Here we have circumcenter. We label it by C. So what did we do? Let's refresh once again. What did we do? We went for drawing a triangle. That is triangle PQR. Then we need to go for perpendicular bisectors of any two sides out of the three. So we went for perpendicular bisector of QR. This is needed. We went for perpendicular bisector of PQ. You can label this also if you want. This is PN. Point of intersection is N. Did we get the point of intersection of both the perpendicular bisectors? Indeed, yes. That should be named as point C. What is that point? The point is termed as circumcenter. What is that point termed as? Circumcenter. Now, C as a center with either CP or CQ or CR as a radius. Sir, we had only one radius here. Here there are multiple. CP, CQ, CR, all are circumradii and they are going to be equal. So if you want, I'll just show you by a dotted line. You can say either CP or CQ or CR. Mind you, all these are circumradii and they are going to be equal. Right? So I take C as a center and CP as a radius. For that matter, you could have taken CQ also and CR also. I take C as a center, CP as a radius and go for a circle. The moment I go for a circle, it will pass through all the three vertices. P, Q and R. You have to be very careful. It should not happen. It should not happen that it goes slightly outside from one side and inside from one side. From my side, I don't have any kind of instruments right now. You have to be very careful in drawing here also and here also. Right? This is what circumcircle is. So how we differentiate incircle and circumcircle? For incircle, we have angle bisectors of any two angles. We have perpendicular bisectors of any two sides. Now, unlike over here, after getting the circumcenter, we directly went for CP or CQ or CR. Here we cannot say IA or IB or IC. No, children. From here I have to go for a perpendicular onto the base. Mind you. Right? Are you getting me? So this is what is the difference. Now here I would like to tell you some techniques and tips. This is what for? This was for an acute angle. So what if I have an obtuse angle with me? Mind you, when I have an obtuse angle with me, my circumcenter will always be outside the triangle. For an acute angle, my circumcenter is going to be inside the triangle. For a obtuse angle, my circumcenter is outside. I can make you understand quite roughly. This is what my perpendicular bisector will be for one side. This is what my perpendicular bisector will be for another side. Don't you think so? So now I have to take this as a radius or this as a radius, or for that matter this as a radius. And when I go for it, see to it that it is a bulged figure. It is a bulged figure. Very much bulged from this portion. Mind you, from this portion, it is very much bulged going on that side. So it should not happen with you people. It should not happen. Care needs to be taken. What care needs to be taken is that if you have a page like this, and then you start drawing your obtuse angle here, you went for circumcenter, and then you realized that, sir, when I was trying to draw, my half of the circle was going outside the page. This should not happen. That's the reason I'm giving you all this. At times you are not aware about it, that how far and how much space you require. Can you see that my circumcircle is going beyond my page? This should not happen. So for acute angle, the circumcenter is inside. For obtuse angle, it is outside. Now comes right angle. So if this were to be my right angle, say, so you know where exactly my circumcenter will be? My circumcenter will be exactly onto my hypotenuse. Mind you, it has to be on my hypotenuse. Not only it has to be on my hypotenuse, but also it should be exactly on the midpoint of the hypotenuse. Right? Those who have not understood, I'm giving you an example. Say my right angle triangle ABC, or say right angle triangle DEF. Say right angle triangle DEF. The measure of D was 6 and that of EF was 8. So by Pythagoras theorem, I am very much aware that this is going to be 10. So we need not measure theory. Right now we are not doing any kind of theory, mind you. But if I know this measurements, in order to draw a triangle, I have to have my measurements of a triangle. So once I am done with my triangle, and if it is a right angle triangle, I can easily say that when I go for a perpendicular bisector, the circumcenter will be exactly at the midpoint of the hypotenuse. Mind you, keep this in mind. If you find your circumcenter coming inside the triangle or going slightly above the triangle, hypotenuse. If your circumcenter comes inside the triangle, that is below hypotenuse, or if it goes above hypotenuse, that means you are wrong somewhere. It should exactly coincide at the midpoint of the hypotenuse. Now with this as a center, say C, CD or CE or CF. Anyone has a radius, you can go for it and draw a circle. Right, children? Are you getting me? Right? Last thing I would like to tell you, because practically when you do it, at that time you'll realize, when you say you are not going for any base angle for incircle, when you say you are not going for any base angle for incircle, so let me say a very small diagram here. You are not going for any base of incircle. You will take only one base and you are not taking the other one. So say this is again LMN. So if I go for an angle bisector of LM and I want an angle bisector of L also, now who shall be acting as base? As we know that I need to go perpendicular from I to the base. So this is I. Now base is not MN. For that the base is LM. So my arc should be like this. Cut, cut, and then here cut, cut. So perpendicular will be like this, and this will be taken as a rate. So when I say base, that doesn't mean every time the horizontal line which you take as base should be regarded as base. When I say base, means from where the two angle bisectors have been drawn. That's what the base is. So here LM turns at your base as your base, and here BC turns out to be your base. Keep this in mind. Moreover, the technique which I told you, what is the technique did I tell you? Circumcenter is going to be inside when it comes to acute angle. It's going to be outside when it comes to obtuse angle, so that this kind of situation should not occur. You have to leave space in a paper. See to it that you have good amount of space. Right? Before drawing a triangle, you need to have a very good amount of space, so that the resultant circle will be slightly bulged, protruded. And for right angle, the circumcenter is going to be exactly at the midpoint of the hypotenuse. Children, keep this three in mind. All these things what I have said, I think so you have very well understood the difference between incircle and circumcircle, right? All the sums are absolutely based on that. if you have learned this carefully, every single sum of incircle and circumcircle is what you can work out, right?